Hello friends, how are you? In today's class, I'm starting our topic again, which was change in state of matter. And in the first class, we discussed about it, but as per me, we should revise it because that was, I think, 4 or 5 days before, and after that, you taken some other classes. So, and there is new students also. So I'm starting this topic again. That is change in state of matter. As we know that there are three states of matter: one is solid, second is liquid, and third is gas. These three states of matter is result of two factors. First is attraction forces between the particles, and second is kinetic energy or thermal energy or vibrational energy. The attraction forces try to particles mix closer, while kinetic energy or thermal energy cause vibration or motion, due to which the particles want to remain separately. That means these two factors, which are opposite to each other, are responsible for the state of matter. Now, in today's class, I am starting our topic again. The state of matter can easily change by two factors: by changing the temperature, or second, by changing the pressure. First one is by changing the temperature, and second is by changing the pressure. So because of that, two, change in temperature or by second, change in pressure, we can easily convert states into each other. Now first hour, we will discuss about the effect of change of temperature. To understand it, we perform an activity in which we take a beaker and put it some ice in it, and also one thermometer is here to measure the temperature, and one glass stirrer to make the motion in the components, so that the entire temperature of the system remain same. Otherwise the lower portion becomes high temperature while the upper portion becomes remain low. That is not good for the activity, so that is glass stirrer is used. Now we put this beaker on a burner. With the help of the iron stand, we clamp the thermometer. Okay, now what is happening here? As we know that with the burner we are supplying the heat, and on the supplying the heat, which is appear in the form of temperature, the increasing temperature here perform two things. One, it increase the kinetic or thermal energy of particles, and second, it decrease the attraction forces. That means increase, and that means decrease. Upper sign, that is increase; lower sign, that is decrease. Okay, now we continuously do this activity till the ice convert into the water, and after that the water start to boil. We perform this activity and continuously note the temperature with the help of thermometer. Now when we plot a graph between the temperature and time, then this type of graph we obtain. Here that portion is showing solid state, this portion is liquid, and this portion is gas. When we perform the above activity, we notice that the temperature of solid continuously increase and reach at a point where solid start to convert into the liquid state. Till all the solid convert into the liquid state, it remain constant. This temperature where the solid convert to the liquid is known as melting point. After the melting process, when all the liquid solid convert into the liquid state, the temperature again start to increase, and again we obtain a constant point where the liquid start to convert into the gas form. till all the liquid convert into gas form. The temperature becomes again constant. This temperature is called boiling. That means the temperature at which liquid convert into gas is known as boiling point. Okay, here two more things: latent heat of fusion, latent heat of vaporization. We will discuss after few minutes. Firstly, we generalize the process of solid to liquid convert into the liquid. As we know, here the temperature is continuously supplying. This I am firstly discuss about the solid state convert into liquid state. What changes are appearing here and why they are appearing? On increasing the temperature of solid, the kinetic energy of particles increases, because as we discussed that the temperature results increase in thermal energy, which results vibration, and vibration, that means motion is related with the kinetic energy. So the temperature increase the increasing the temperature of solid increase the kinetic energy of particles, due to which the particles start vibrating with the great speed. When the kinetic energy becomes enough, the particle leave their fixed position and move rapidly. Finally, a stage is reached when the solid melt and it convert into liquid. This conversion is known as melting or fusion, or simply we can say this process. If we are defining, then we use this or the process of change solid into liquid is known as melting or fusion. Okay. Second thing about that process, conversion of solid to liquid, melting point, that was melting or fusion. Okay, if I am use that melting point, or what is the melting point? The temperature at which a solid melt into liquid at atmospheric pressure, at atmospheric pressure is called melting point. Here let me clear you, the pressure should be atmospheric, because if the pressure is changed, then the melting process required temperature is also changed. So the melting point, that in the definition of melting point, there should be atmospheric pressure. It should be atmospheric pressure. Got it? The melting point of water is 0 degrees Celsius, or in Kelvin we use 273.16, or simply we use 273 Kelvin. Now the question comes in our mind that what is the Kelvin, what is the degree Celsius? So let we discuss about something about that. That is a general point of our discussion. There are various scales of temperature, out of which you are familiar with the two. One is degree Celsius and second is Fahrenheit. Fahrenheit is medically used, while in physical world the degree Celsius and Kelvin, these two scales are used. Kelvin is a system international scale, that means it is used internationally to describe the temperature. So we have to know that how we convert the degree Celsius, because our thermometer showing the temperature in degree Celsius, but we have to use the Kelvin scale. Kelvin we have to convert into Kelvin. If we have to convert degree Celsius into Kelvin, then we have to add 273. We have to add 273 in degree Celsius value. Then the find answer is Kelvin. For example, 0 degree at 273, then 273, that is the Kelvin. 0 degree Celsius or 273 Kelvin. Both are temperatures. If we have to convert Kelvin into degree Celsius, then we have to subtract or minus 273. Okay, that means for example 473 minus 273, that is the answer is 200 degree Celsius. To 473 Kelvin temperature is equal to the 200 degree Celsius. Now our one more thing, that is latent heat of fusion. To understand it, let me consider our graph again. Here the supplying heat continuously increases the temperature, but when it melting process start, then the temperature becomes constant, and after that it start to increase again. Now where this heat is going on, normally the heat is generalized with the temperature. As we know, burner is started and continuously supplying the heat, so heat is also supplying here, but the temperature is not rising. That means it is hidden. That is hidden. That's why a term latent heat is used for that kind of energy. Since it is fusion or melting process, that's why it is known as latent heat of fusion. Now the questions comes around that we understand it, but what is this? Here in this when the temperature reaches at melting point, then the absorbed heat is utilized to break the attraction forces between the solid particles, because till the attraction forces breaks down, the solid does not convert into the liquid. For conversion of solid into liquid, we have to break down the attraction forces which are present between the solid particle. During this period, the energy is used to break down these attraction forces. Hence it do not show any increase in temperature. That means remain hidden or latent heat. Got it? Now it is and now let me describe about it. It is observed that the temperature does not change after reaching the melting point till all the solid melt and convert into the liquid state. Here, the absorbed heat get used up in changing state by overcoming the force of attraction between the particles. So this absorbed energy does not show any increase in temperature and remain hidden. It is called latent heat. Does okay? Understand it? Now, what is the definition? The definition is the amount of energy that required the amount of energy that required to change 1 kilogram of solid into liquid at its melting point is called latent heat of fusion. This is known as latent heat of fusion. Got it? The amount of energy that required to change 1 kilogram of solid into liquid is known as at its melting point. At its melting point is called latent heat of fusion. Clear? Now the question for you: at 0 degrees Celsius, water and ice both are present, because 0 degrees Celsius is the melting point where water is also present and ice is also present. Now the question is, which has more energy? The water has more energy in the form of latent heat, because the when at 0 degree it receives the latent heat, then it converts into water, so water has more energy in the form of latent heat of fusion. Now we move to the second process, which is conversion of liquid into gas state. It is also similar with the conversion of solid into liquid state. Again, after the converting the solid into liquid, the supplied heat increase the temperature. So on increasing temperature of liquid, the kinetic energy of particle increase, as we discussed in the case of solid. Thus particles start vibration with the great speed. When the kinetic energy becomes enough, the particle break attraction forces of the liquid state. In this state, the liquid start changing to the gas. Here the heat finally, the kinetic energy of particles becomes enough, that means more than attraction forces, then the liquid start convert into the gas. This process of change liquid into gas is known as boiling or vaporization. Similarly, like the melting point, we can also define boiling point: the temperature at which a liquid start boiling. The temperature at which a liquid start boiling at the atmospheric pressure is known as boiling point. For the water, the boiling point is 100 degrees Celsius or 373 Kelvin temperature. Now, similar, the latent heat of vaporization similar with the latent heat of fusion. The amount of, here if I am showing in the graph, that energy, Okay, it is also same as the latent heat of fusion. The amount of energy that required to change 1 kilogram liquid into gas at its melting point is known as latent heat of vaporization. Okay, now the similar question as we discussed about the 0 degree Celsius water and ice, which has more energy at 100 degree Celsius, steam or water? The answer is steam, because at same 100 degrees Celsius temperature it has more energy. It has more energy in the form of latent heat. Okay, so steam has more energy at 0 degrees Celsius in the form of latent heat than water, which is also present at 100 degree Celsius. Now the third process, which is sublimation. Now the question comes in our mind, what is sublimation? When a solid directly converts into gas without passing the liquid state, then it is known as sublimation. For example, there are naphthalene balls which we put in the woolen clothes in our home. After some time they becomes disappear without leaving a liquid, because they directly convert into gas state. This process of conversion of change of solid indirectly into gas without passing liquid state and vice versa, that means gas to directly solid, solid directly gas, gas directly solid without passing liquid, that means liquid state is missing here, very short lived, is known as sublimation. Okay, the conversion of or change solid state directly into gas without passing liquid state is known as, is called sublimation. We can use vice versa here also. To understand it, we can perform an activity. In a china dish, we put ammonium chloride. We put ammonium chloride and a inverted funnel placed on it with the cotton plug. This cotton plug, that is normal cotton like that, which prevent the passing of the gas outside from this setup. Okay, now when we give the heat, the ammonium chloride start to convert into vapor state, when this vapor, that is vapor of ammonium chloride, rise up and strike the cool surface of the funnel, then it directly convert into solid and deposited here. If it convert into liquid, then it will fall down, but here there is no appearance of any kind of liquid on the walls of the funnel or as well as on the china dish. There is appearance of the solid of ammonium chloride here, and that is here. So with this activity we can say the solid directly convert into the gas state, and here in cooling it directly convert gas to solid. So there is no presence of liquid state in this activity. So this activity show the sublimation process. Okay, so there are three things. First, solid into liquid. Second, liquid into gas. Third, solid into gas. Okay, so if I'm summarize all of these things, then that kind of graph is that kind of picture is clear. Solid state, liquid state, gas state, these states convert into each other. The solid convert into liquid is known as fusion or melting. The liquid convert into gas is known as vaporization. The solid directly convert into gas is known as sublimation. If I'm invert it, reverse reaction, reverse process, then gas convert into liquid is known as condensation. Here one thing is wrong, that and that. Let me clear it. Sorry for that. is correct. Liquid convert into vapor, gas state, vaporization. Gas into liquid state is known as condensation. Okay. Liquid convert into the solid is known as solidification. These terms are not in our syllabus. We generalize uh, these terms with the some simple definition that the conversion of gas into liquid is known as condensation. The conversion of liquid into solid is known as solidification. These are uh, opposite of vaporization and fusion. So, and sublimation, either convert of solid into gas or gas into the solid, is known as sublimation. Okay, hope you like it. Thank you.